Most people think the speed of light is just Einstein's rule, some arbitrary cosmic speed limit slapped onto the universe. But the real answer is way weirder. The speed of light isn't a rule, it's a consequence. It's literally built into the structure of space and time themselves. And understanding why requires a journey through 400 years of physics, starting with Isaac Newton staring at the moon. Newton realized something wild. The moon is falling. Right now. Constantly falling toward Earth. But it's moving sideways fast enough that by the time it falls, Earth has curved away beneath it. It keeps missing. That's what an orbit is: perpetual falling. Newton figured this out by asking, what if the same force pulling an apple to the ground also pulls the moon? What if gravity is universal? That insight kicked off everything that followed. Now jump ahead 100 years. Astronomers are watching Jupiter's moons, timing their orbits with precision. And they notice something strange. Sometimes the moons arrive early, sometimes late. The variation correlates with Earth's position. When Earth is closer to Jupiter, the moons seem faster. When farther, they seem slower. The timing shifts by about 16 minutes over Earth's year. Subscribe and like for more videos that explain what's really happening beneath the surface. Because what we're about to uncover changes how you see reality. The astronomers could have blamed their math or said Jupiter's gravity was doing something weird. But a Danish astronomer named Ole Rachmer had a different idea in 1676. What if light takes time to travel? What if when Earth is closer to Jupiter, the light showing us the moons has less distance to cover, so it arrives sooner? And when Earth is farther, the light takes longer, so the moons appear delayed? He calculated. The 16-minute variation matched the extra distance light had to travel across Earth's orbit. Boom! Speed of light discovered by accident while studying gravity. Light isn't instantaneous. It travels at a finite speed, about 300,000 kilometers per second. For 200 years, that was just a number. Light moves fast. Fine. But then in the late 1800s, physicists started asking, fast relative to what? If you're on a train moving forward and you throw a ball forward, the ball's speed relative to the ground is your throwing speed plus the train's speed. Speeds add common sense. So if you're on a spaceship moving toward a light source, shouldn't you measure light moving faster than someone standing still? And if you're moving away from the light, shouldn't you measure it moving slower? That's how velocities work for everything else. Except experiments said no. The Michelson-Morley experiment in 1887 tried to measure Earth's motion through space by checking if light speed changed depending on Earth's direction of motion. They found nothing. Light moved at exactly the same speed in every direction, regardless of Earth's motion. Every subsequent experiment confirmed it. Light always moves at the same speed for all observers, no matter how they're moving. This is bizarre. If you're in a car going 60 miles per hour and another car passes you going 70, you see it moving 10 miles per hour relative to you. But if you're in a spaceship going half the speed of light and light passes you, you don't see it moving at half speed. You see it moving at full light speed. Same as someone standing still? How? Einstein, in 1905, said, "You have to give up something. You have to give up the idea that time flows the same for everyone. Time is not absolute, neither is space. They're flexible. They adjust to keep the speed of light constant." Here's the key insight. The faster you move through space, the slower you move through time. Not as a feeling literally. If you're on a spaceship moving close to light speed, your clock ticks slower relative to someone stationary. Distances contract. The universe reshapes itself around you to keep light moving at exactly the same speed no matter what. This sounds insane, but it's been tested. Particle accelerators prove it every day. Particles moving near light speed live longer than they should because time slows for them. GPS satellites orbit Earth at high speeds. and their clocks run slightly slower than clocks on the ground. Engineers have to correct for this, or GPS would fail. Cosmic rays particles from space moving near light speed reach Earth's surface when they should have decayed in the upper atmosphere. They survive because time moves slower for them. Nature doesn't care about your common sense. It plays by different rules. Now here's why light speed is the limit. To accelerate something, you add energy. The faster it goes, the more energy you need for the same speed increase. As you approach light speed, the energy required grows without bound. It takes infinite energy to reach light speed. You can't do it. Not because of engineering, because of the structure of spacetime itself. Light moves at light speed because light has no mass. Anything with mass can never reach light speed. Anything without mass must always move at light speed. Light doesn't accelerate for rest. It's created already moving at light speed, and it can never slow down or speed up. Light speed isn't a speed limit in the sense of a rule. It's the conversion factor between space and time. It's the universe's way of saying, space and time are not separate things. They're two aspects of one structure spacetime. Feynman's genius was showing how these discoveries connect. How confidence in one law helps you discover the next. How questioning why Jupiter's moons seemed wrong led to finding light speed. How each breakthrough creates an avalanche of new ones. Newton's gravity led to Rivmer's light speed. Light speed led to Einstein's relativity. Relativity led to quantum mechanics, particle physics, cosmology. Each step depended on trusting that nature is consistent, that if something doesn't make sense, you're missing something, not that nature is broken. And here, as the philosophical takeaway, your intuition about space and time is wrong because it was built for slow speeds and weak gravity. You evolved to throw rocks and chase animals, not to navigate near light speed. Your brain has no business being correct about relativity, and it isn't. But nature doesn't care. Nature enforces her rules, whether you understand them or not. The speed of light isn't a speed limit. It's the shape of reality. It's the rate at which cause and effect can propagate. It's the structure that connects space and time into a single fabric, and it's not negotiable. You can't go faster. Not with better rockets, not with more fuel, not with future technology. The universe is built this way. And once you accept that, once you stop demanding that nature conform to your expectations, and start listening to what the experiments tell you, reality becomes far stranger and far more beautiful than anything you imagined.